Good morning, Swans and Falcons, and welcome to Monday's maths lesson. So today is the 1st of March. Can't believe it's March already. Where did February go? And here is your learning intention for today. Can I understand that different shapes can have the same area? Okay, so let's do some warm-up questions first, just to get our maths brains going before we move on to the main part of the lesson. I've got 4 questions there for you to think about. Which unit of measurement would you use to measure a P? It'd be kilometres, metres, centimetres or millimetres. What is 75% of £60? What is a half times 2/3? And then last one, 4x minus 1 equals 35. What does x equal? Okay, so pause the video, have a go at those and then restart when you're ready to go through the answers together. Okay, let's have a look then. Change the colour of my pen so that hopefully will stand out. Let's go pink. So, the first one, which unit of measurement would you use to measure a P? Wow, P's, are they big? Are they small? They're little round green things, aren't they? And probably they are smaller, tend to be by petit pois or the normal size pea, garden peas, but generally they're smaller, aren't they, than a centimetre. So, hopefully you all said that you're going to use millimetres to measure those with, because I think that's the most sensible unit of measurement to use. What about 75% of £60 then? Now there's 2 ways you could have worked this out. You could have worked out what 10% was and then 70% from that, and use your knowledge of 10% to work out 5%. Or you could think about 75% being 3/4 of 100%, okay? And worked out what a quarter was by dividing 60 by 4, which would be 15, wouldn't it? 60 divided by 4 is £15, but then I've got 3 lots of that, haven't I? So times that by 3, dodgy times, but never mind, equals £45. Okay, practicing our revision of multiplying fractions. Remember, they're quite easy, they're one of the easier ones. So we have to multiply the numerator together and then multiply the denominator together. So 1 times 2 is 2, 2 times 3 is 6. And can we simplify that fraction? So I've just realised that the pink doesn't show up very well, does it? Let's change it back to green. Whoop. So we had 2 over 6. And 2 is a factor of both 2 and 6, so we can simplify that by dividing top and bottom by 2 to give us 1/3 as a fraction in its simplest form. And the last one, 4x minus 1 equals 35. So 4x minus 1 equals 35. Then 4x on its own must equal 36, mustn't it? Because 36 minus 1 equals 35. So 4x, we know equals 36. And remember, when a number is next to a letter, that means times. So 4 times something equals 36. If we know our times tables well enough, we'll know that 4 times 9 equals 36. So x equals 9. So hopefully you got on okay with those questions, but in any case, I've got your brains warmed up and hopefully talking through will help you to understand on them. So I have an oblong, or a rectangle here, and each square is worth 1 centimetre. Okay, so what are the dimensions of my rectangle? Well, how many squares do we have going along the top? We have 1, 2, 3, 4, don't we? So it's 4 centimetres and 1, 2 going down. So 2 centimetres going down, and we can work out the area. We know that each square is 1 centimetre square. We can work it out by counting the squares. So 1, 2, 3, 4, 5, 6, 7, 8. So the area of that shape is 8 centimetres squared. Okay. Let's have a look at some other shapes. Have a look at these shapes and see what you notice about the area of these shapes by counting up the squares. If one square is 1 centimetre squared, add them up and work out what the areas of each shape is. Okay, welcome back. So we have, how many do we have here? 1, 2, 3, 4, 5, 6. Okay, so this one is 6 centimetres squared, and its dimensions are 3 by 2. What about this one here? 1, 2, 3, 4, 5. Wow, it looks quite different, doesn't it? But it's also 6 centimetres square, but in this case, it's 6 by 1. And this one, 1, 2, 3, 4, 5, 6, also 6 centimetres squared. What do you notice about these two here? They're exactly the same. What do you notice about the lengths of the sides? Pause the video and have a think. What do you notice about the lengths of the side in relation to the area itself? So about 2 and 3 in relation to 6 and 1 and 6 in relation to 6. What do you notice? Pause, have a think, and then restart when you're ready to have a chat about it. Okay, so if we just focus on these two here, hopefully you notice that 2 and 3 and 1 and 6 are all factors of 6, okay? And we can use that information to help us answer questions relating to shapes. So quite often in a SATs paper or a test paper, you might be asked to draw 2 shapes that have the same area but that are different shapes, okay? So if I want to draw 2 shapes with an area of 16 centimetres, it might help me to think about what the factors of 16 are. So pause the video, see if you can write down all the factors of 16 and then restart when you're ready to move on. So the factors of 16 are, remember factors come in pairs unless it's a special type of number. What number is it? That's right, unless it's a square number, because obviously if it's a square number then a number multiplied by itself, the factor. So we have 16. Let's draw a line down. Oops. I don't know why I put it either side. That's very silly of me. Let's do it again. So we have factors of 16 going across. Okay, so we have 1 and 16, don't we? Then thinking logically, the next one would be 2. But how many times does 2 go in 16? It goes 8 times, doesn't it? And what would be next? Do we have... Well, it's a square number, isn't it? So then we have 4, and 4 multiplied by itself equals 16. And that's all of the factors of 16. Okay? So if I had a question that said to me, draw 2 shapes with an area of 16 centimetres, I've got the dimensions of the shape that I would need to have. I'm going to put the 4 there just to help remind myself that it's 4 by 4. I could do a shape that was 1 centimetre by 16. I could do another shape that had 2 centimetres by 8. So I'm going to do that one because I think by 16 I might run out of squares on this board. I don't think it goes up to enough. So 2 by 1, 2, 3, 4, 5, 6, 7, 8. 2 down. And 8 across. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And my other options do 4 by 4. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then we can double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've got 2 different shapes, both with an area of 16 centimetres squared. Just by looking at the factors of the number, that has enabled me to draw 2 different shapes that have the same. So from this, what do you notice about, so this one is 8 by 2, this one's 4 by 4. What do you notice about how we calculate the area of a shape? If we didn't have the squares to be able to count them, how would we calculate the area of a shape? That's right, we multiply the length by the width, don't we? What I want you to do is go away and have a go at the sheet. If you have any problems, then please message us on the blog and we'll try to help you as best we can. And I look forward to seeing you tomorrow for more another lesson on area. And I think perimeter tomorrow as well. And I'll see you tomorrow. Bye.